Bondi, Golden, Hoyle, Jeff Burbidge. But in 1963, they were alive and well, and they realized if the quasars were at the distances indicated by the raw data, steady state was wrong. And so they invented the idea of non-cosmological redshifts. Light moved to longer wavelengths, but not by the expansion of the universe, by something totally unknown to physics. Totally unknown to physics now, because it turned out not to be the right answer. The quasars really are far away from us, and the universe has changed with time. So that was a case where astronomy tried to invade physics and failed. Oh yes, astronomers can make molecules by looking around, not found in the laboratory. HC9N. Another couple. There's another one, another image, but let me tell you about it now. The element helium. Raise your hand if you have never had a helium-filled balloon. I'm glad. Saddest thing in the world is never to have had a helium balloon. But you know, you mustn't buy it yourself. Your helium balloon must be given to you by somebody who loves you, or it doesn't count. Right? So if you've only ever had a helium balloon by buying it yourself, get somebody who loves you to buy you one. They're cheap now. But helium was first discovered by spectroscopy of the sun. That's why it's helium, Helios, the Greek sun god. And it was discovered by Norman Lockyer. And the physicists and the chemists deeply resented this until Ramsay found helium on Earth. And then the astronomers said, oh, by the way, there is also coronium in the sun, nebulium and nebulae, asterium, aldebaran. The astronomers invented a bunch of new elements, none of which were right. Helium was true, but none of the others were. Another attempted invasion that failed. Yes, dark matter. Oh, sorry, I should say non-zero lambda. I just forgot to look at the lambda in. Solar neutrino, this is a serious one. The stars run on nuclear energy. There's no other way to understand how the sun can have lived as long as it did and how stars can be as bright as they are with the masses and compositions they have. The stars live on nuclear energy. Nuclear energy is made by nuclear reactions. Surprise, surprise, surprise. They're fusion reactions. There are fusion bombs on Earth and there are fission bombs. And it was George Gamow who said that the sun tells us the right scale for fusion and the right distance from which to observe it. But that stars run on nuclear reactions means that they must produce neutrinos. And long ago, moderately long ago by my standards and long ago by many of yours, a chap named Ray Davis started building a detector to look for the neutrinos coming from the nuclear reactions in the sun. And he didn't find anything. For years, he kept saying, well, we have an upper limit of about a third of what the theorists say should be there. And it involved the chemistry of getting stuff out of his detector. It involved the physics of the nuclear reactions. It involved the astronomy of trying to understand the conditions at the center of the sun. And so the physicists and the chemists said, well, the astronomy is wrong. The astronomy and the physicists said the chemistry is wrong. The chemistry and astronomy said physics is wrong. And they said the physics was wrong in the nuclear part. It turned out, in the end, it was the physics that was wrong, but not nuclear physics. It was the physics of neutrino production, neutrino propagation, the physics of the weak interaction. And that had been in the inventory for years. I've got Pontecorvo there. Pontecorvo was on one of my lists of anniversaries because he also was born 100 years ago. And he was the first to say, well, neutrinos come in flavors and they can, it's as if, you know, you buy a vanilla ice cream cone, you take it home and you open the package and it's strawberry. Neutrinos do that. They oscillate amongst electron, tau, and mu flavors. And Pontecorvo said they would do that. He was absolutely right. He also fled. Well, you can tell from the name Bruno Pontecorvo, he was Italian, right? And he worked in the US for a number of years, and he fled to Russia in the McCarthy era, which you're all too young to remember, right? Well, many of you. But he thought he was going to be chased down as a communist sympathizer, and so he fled to Russia. Turned out he was fleeing where no one pursued. He was not, in fact, on any McCarthy list of bad people, but he fled, and he was only allowed out and came back to his family in Italy very late in his life. I met him a year or so before he died of Parkinson's disease. But he was the one who first understood that the solar neutrino problem was not the fault of the astronomers. It wasn't the fault of the chemists either, it was the fault of the physicists. What Moseley did. Okay. I think this is the core of what I really want to say. Moseley was a laboratory experimenter in England back in the days when you did experiments with a thing and a string, before the wars. There was a British, again, geophysicist named Teddy Bullard, whom I encountered without knowing who he was. And what he remarked to me was that what scientists had learned from the wars was the difference between $1,000 and $1 million and what you could do with each. I think you would now say maybe the difference between $1 million and $1 billion and what you can do with each. But the bottom line was that scientific experiments had never had any money, and so people had to be awfully clever. Moseley was awfully clever. He made little tiny plates of metals, and he bounced electrons off them, and he measured the X-rays that came out. And from that he learned that the energy of the X-ray went as the charge on the nucleus of the atoms in the little plate as z squared. And from this he could sort out properly how the periodic table should work. Periodic table we normally credit to Dmitry Ivanovich Mendeleev, but Mendeleev's table had glitches in it. There were atoms in the wrong places, elements in the wrong places. The rare earths were a mess. Moseley's work enabled us to understand how the atoms, how the elements fit into a linear sequence. From hydrogen 1 to uranium 92. He actually only did aluminum to gold, but he did an awful lot of them. And he sorted it out, he put the rare earths in the right place, and he showed that from aluminum to gold there were only 3 gaps. 43, which is technetium, artificial, 61, which is promethium, and 72, which is hafnium. Now I know this is not going to go over with you because it didn't work for an audience of engineers the other night. But I claim the atomic weight of hafnium is exactly half the atomic weight of holmium. Well, there is an element called holmium, right? And the atomic weight of hafnium is half that of holmium. Well, okay. Some of you are better educated than the average engineer, which is very interesting. Some of my best friends are engineers. My father was a chemist. In fact, let me say that right now. One of the real trespasses, and I will come back to this again too, was the grabbing of the territory of how atoms are constructed and what they're made of by physics, taking it away from chemistry. My father resented that to his dying day. Okay. Yes, pair reversals, gaps, isotopes. Well, the bottom line is that Moseley's ideas, the apparatus he built and the experiments he did, and the paper he first published in 1913, before he went off to be killed at Gallipoli, which is the same as the Hellespont. You know, there's the Black Sea, the Dardanelles, the Sea of Marmara, and the Hellespont. Gallipoli is the coast of the Hellespont. That's the one you're supposed to be able to swim across, but I wouldn't try it if I were you. It's been swum a number of times, but they didn't all survive. Well, Moseley didn't survive either. He was shot by what we say is a Turkish sniper. No guarantee he was actually Turkish. Astronomical implications. The amount of each element to be found in the sun or other stars or galaxies or quasars as a function of atomic number is a fundamental fact of the universe which has to be understood if you want to understand the universe. You may feel it so much bigger than you are you don't need to understand it. I think that's wrong. I think it's interesting that we can, at some level, understand many things about the universe, and in particular the chemical composition of the sun and stars and galaxies and quasars. And to get that right, you have to know which element belongs where. Aston is an astronomy side thing, but getting the periodic table sorted out was what enabled Burbage, Fowler, and Hoyle working together, and Cameron working by himself at the same time to understand how the elements were produced by nuclear reactions in stars and why there are the amounts of each that there are. Now, most astronomers, many physicists will have heard of Burbage, Fowler, and Hoyle. Mostly they will not have heard of Cameron. Now, there are a bunch of things that go into that. Perhaps the most important is your press agent. Black holes swallow almost anything, but they also radiate back. The first person to recognize that was Jacob Bekenstein, Raise your hand if you've heard of Bekenstein. Nobody. That's what I was expecting. Okay. The process is generally called Hawking radiation. Raise your hand if you've heard of Steve Hawking. Okay. He had a better press agent. He still does. He was actually a postdoc in Cambridge at the same time I was, so I knew Steve when he could still walk and talk. In any case, the fact that B squared FH had a better press agent, well, Willie Fowler actually got the Nobel Prize, and Cameron certainly did not. The other thing is you have to publish in the right place. Cameron was up at Chalk River, which was the Canadian equivalent of Oak Ridge. That is to say, it was a classified nuclear reactor facility, and he published in reports that were classified. But the bottom line is that with good abundances and with the understanding that Moseley brought, it became possible to understand how elements were made in stars. Resisting spectroscopy? Oh yeah. Auguste Comte, a very well-known philosopher, if you happen to know any philosophers, said we could never, ever know the chemical composition of the planets and stars. 20 years later, Bunsen and Kirchhoff showed that the sun had sodium and iron in it. What do you say to a philosopher of this sort? Yeah. Some of my best friends are philosophers, too. Maybe not after tonight. And I said this before, that